Hey, how's it going? It's Keith Townsend from the CTOadvisor.com, and you're watching a replay, at least a re-recording of the webinar I gave on serverless infrastructure October 31st, 2017. For more webinars and information on technology in general, you can visit me at thectoadvisor.com or follow me on the web at CTOadvisor. First, a little bit about myself and why should you even pay attention to me. I have had a career in IT that spans about 20 years, easily 3 decades. Started the career in the 90s, spent a couple of years at PwC as a management consultant. So I bring a perspective that includes the business or management angle as well as IT, hence the handle at CTO Advisor. So let's jump right into the content. First off, there are servers in every data center. It's not a data center without servers. Therefore, there are servers in serverless. At some point, somebody racks and stacks servers, installs a OS, installs the control plane for servers that run serverless. I've seen the term CPU-less, I think, the other day. And I think this is all about context. It's all about the developer. Microsoft's former CEO once famously got on stage and yelled, "Developers, developers, developers." There's a bit of, I think, truth in that. I think developers are the current hotness in enterprise IT and just business in general. The app is the most important part of the data center, along, of course, with the data. Without the app and the data, there's really not much point for infrastructure, data centers, etc. And this is all about perspective. We've had this view of enterprise resources in the past that has centered around servers, server related infrastructure. So how much RAM, CPU, memory, disk space usage does a developer need to even start developing the application? The aim of products or solutions like serverless is to get away from that abstraction layer, to abstract at a higher level where developers are only worried about code. I think I really love this. I know I really love this picture from Google, specifically the Google Apps Engine team. Hat tip for them for creating the image. But the basic concept is that you have infrastructure, and of course you're going to have bare metal servers. On top of those bare metal servers, you might run virtual machines or containers. From a developer perspective, they've consumed one of those 3 units. They've either consumed containers, virtual machines, or bare metal servers to create applications. How are those applications created? Well, any application, doesn't matter if it's a monolithic application or an application built on microservices. We start with the basic layer of a function. That function can be something that runs inside of a container. It can be something that runs inside of a container inside a virtual machine. It can be something that runs inside of a container inside a virtual machine, inside on bare metal. But the base function is the starting block for an application. The developer starts at that point, thinking through what functions do they need to develop an application. The disconnect comes in is when, after that code is created, they have to worry about the OS. Now, the containers help to reduce, I think, some of the reliance on virtual machines and bare metal, but it doesn't go away completely. You still have to worry about OS updates. What version of OS do you want? What dependencies inside the container needs to be there? There's still this setting up of the actual infrastructure to write code, even when you're using containers to package and ship that code. Containers solve the packaging and shipping of code inside of an OS, but it doesn't extract away the OS. The goal of serverless is to completely extract away that infrastructure. So a word on microservices, because I mentioned this before. There's this concept that we can build every application based on a microservice, and that microservice will therefore run in containers. So what are the challenges with microservices and containers? As I mentioned before, you're still focused on compute resources. Even if you're using Docker Enterprise Engine, that has to be given a set of underlying resources. Those resources have to be managed. Those container images have to be pulled down, updated, maintained. There's still a container management and orchestration challenge posed by those solutions. And then there's the concept of security. Securing a container, quite frankly, we haven't worked out all those issues in the industry. A container shares the same OS kernel as the host OS and other containers, which means that there's the possibility for a container escape and for someone to basically own the host operating system or other containers. So containers have a security issue that, it's for different organizations. It's at varying degrees. We're starting to tackle those issues, but there are security challenges posed with containers and microservices in general. So let's talk about the types of serverless, because again, this is all about perspective. If you look at serverless at its core, a service like Lambda or Azure Functions or Google Cloud Functions, they're basically platforms. And on surface, you might ask yourself, how is that different from Salesforce.com, Cloud Foundry, a public cloud service? Interesting conversation over at the CNCF, the Cloud Native Compute Foundation, about the term serverless. Great debate between representatives from AWS, folks from open source projects like OpenFast, Alex Ellis, who were talking through the definition of serverless. AWS was pushing for this definition that said basically serverless has a zero cost when it comes to idle time. And Alex over at OpenFast was like, well, no, hold on. That's not true, because if I put my my functions as a service application inside of an enterprise, the enterprise has to pay for those idle services. We'll get into all of, what does that mean a little bit later when we dive into event-driven compute. But the concept basically boiled down to, it depends on your perspective. Again, if you're the developer, you're just looking at code in any one of these platforms, whether it's Salesforce.com, Cloud Foundry, public cloud. If you're using services, public cloud services like directory services, database, a MySQL instance, and AWS that has no access to the server OS or some AI, a machine learning platform, you're just writing code to that platform. You don't care anything about the servers and those platforms when they're hosted in the cloud. You're just using the APIs and the code environments provided by those services. And event-driven compute, you're keying off some event and you're writing, again, code that runs against that. If I put either one of these services inside of my data center, I have to worry about servers. Maybe not from the developer perspective, but my operating team, someone within my team, has to rack, stack, install operating systems, install OpenWhisk, install OpenFiles, install NUCLIO, Nucleo. I don't know how to pronounce that yet. I'll have to reach out to them to find out how to pronounce that. If you install those services inside of your data center, from the operations team, there's definitely control plane, servers, OSs, networking, and etc. that you have to worry about. As a developer, you still consume that from a serverless perspective. That abstraction still happens for the developer, just not for the rest of the operations team. So let's give an example of a container-based microservices. This is basically for us infrastructure focused folks to help wrap our minds around a microservice. And I think DNS is a great example to help break it down. So in a traditional environment, if we wanted to create a high performing DNS cluster, we might take several VMs running Ubuntu, install bind on those, and then put a load balancer in front of it. So a VIP in front of those DNS servers, and allow that VIP to load balance across those multiple servers. Obviously, highly available platform, robust, can handle potentially hundreds of thousands of requests a minute. And we build it for, basically peak. There's the rock solid solution. However, from a, just a very broad term, that's super inefficient. Let's say that let's say you're a US based company and that DNS is only hit that hard during business hours. During non-business hours, that huge capacity may only get used by 10% or less, but yet I still have, let's say, 15 Ubuntu virtual machines running in order to wait for that load. If I had an instant burst of activity, I could use something like a sleep mode on the OS. But if I had an instant burst of activity, spinning up those additional bind instances might take some time enough that a DNS request might actually time out from a client. Well, this is where the concept of containers come into play. I can do the same thing, wrap all of that DNS bind and its dependencies in a container, and then throw that image out to a orchestrator like Kubernetes, still have the load balancer in front. However, the major difference is I only use resources as needed. So during non-peak hours, I might only have a couple of containers running DNS for redundancy, but during peak, the auto scaler will automatically kick up these new containers in microseconds, service requests, and then when demand goes away, we like to call, have this comparison in IT, cattle versus pets. Instead of having all these pets Ubuntu bind servers running, I now have cattle, and I can, those instances can just go away. I've created a microservice within my data center of DNS, and I'm using containers to be able to scale out as needed. Let's take a little bit more complex of a solution. Let's talk about the actual application that AWS likes to flaunt out as a example of how you combine microservices at the back end of your application and heavier front end applications to create an application with basically no back end servers administered by the customer. It's pretty, I think it's a pretty good example of serverless technologies. So let's first start at the ends, where the heavy code, so to speak, is placed at. You have encoders on the left-hand side of our image, and on the right-hand side of our image, we have consuming clients. So on the left-hand side, this might be a laptop with, let's say, I use Camtasia to edit this video. So editing software called Camtasia. And on the right hand side, there's live stream clients. So on your mobile laptop or your mobile phone, you might have a CTO Advisor application, or on your mobile client, you might have a CTO Advisor app that allows you to connect to the CTO Advisor service to watch these videos that I create. What about the middle? What about that front end? Well, starting from the left, moving over to the right, I would encode this video, upload it using AWS CloudFront to a S3 bucket. Once I uploaded it to an S3 bucket, S3 creates an event. This is where we get this concept of event-driven compute. Once S3 creates the event, it alerts Lambda to execute a Lambda set of functions. So AWS chose to kind of break out all these functions. This could be a single function, or it can be multiple functions. In a single function or in multiple functions, it basically creates a set of cascading Lambda functions. The first one is to create a copy of the video. Then after it creates a copy of the video, it'll create a 480p transcode of the video for larger screens, a 360p transcode of the video for smaller screens, audio only transcode for those devices that are headless, meaning no display, a thumbnail so you can easily browse the various CTO Advisor videos, and then QoS analytics for either infrastructure or for my own consumption. All of those Lambda functions create output to a S3 playback bucket. Then CloudFront, again, another AWS web-facing service, allows my front-end clients to connect to that S3 backend for playback. So from the left to the right, there are no server OSs involved in this. I've created a set of code that is stored in Lambda and only executes upon specific events triggered by S3, a completely serverless application. So some obvious question, in this case of Lambda, where's the code? Well, the code is basically stored within AWS in the S3 bucket, and it only executes when you need it to execute. Well, when does it need to execute? Well, when it's triggered by a AWS event, something like a CloudWatch event, a S3 event, a MySQL service event. There's several events that can trigger your code to run. Well, what does it run in? Practically, it runs in a container. But how are those containers sized? They're sized based on memory. So the one knob that the developer has is the amount of RAM that it takes to run a process inside of a Lambda function. And the key part of this is, I think, really important. We'll go back to our example application. I mentioned that we could do all of these functions in a single set of Lambda code. Lambda limits the amount of time that a function can run to only 5 minutes. So if I can't complete all of that video transcode in 5 minutes, I need to break the function down to yet a smaller microservice so that I can fit it into the 5 minutes. I do have the lever of memory to increase basically CPU and resources so that it can save me a little programming time to not have to break it up. But basically, you have that ability to control code based on the amount of RAM you put to it, making sure that whatever you execute in Lambda only takes 5 minutes or less. And Lambda scales and is based on the number of events. So that's cost from a cost and capability perspective. And this is can be both good and bad. One, it's AWS. So from most of our environments, this means unlimited scale. You don't get charged for Lambda until you've reached more than a million invocations of Lambda. So that's an awful lot of instances. People can use Lambda to actually save a lot of money. If you've built this previous app with a traditional 3-tier layer of server, web server, application server, database server, then you're going to pay for all three of those instances as long as they're running. And in traditional applications, that's basically forever. In our application, you only use these resources. Obviously, you're going to pay for your S3 storage, and you're going to pay for data transfer costs, which you'd have still with your traditional 3-tier app, but you're not going to pay for any of this transcode functionality if you stay under 1 million events a month. Where does this break? Well, Lambda scales bigger than most of our infrastructures can handle. So if you're in a mixed environment and you can run 1 million simultaneous, I'm just throwing a number out there, 1 million simultaneous Lambda events, and the persistent storage is a MySQL database, well, you have the potential to depending on demand, to overwhelm your MySQL backend. So AWS, in the case of Lambda, most definitely gives you control over the number of events that you can run at one time. All right, so hopefully this has been helpful. Let's close this out. First off, there are servers in serverless. This is all about perspective. From the developer's perspective, there are no servers on the back end. A good question I got from the original webinar was, well, shouldn't developers know something about the back end? And the answer to that question is yes, it helps. In our most ultimate example of DevOps in all of enterprise IT is Netflix. In Netflix, there is no differentiation between back-end operations and the front-end application. Those things are integrated together. Developers build in systems into the front-end application that take into account the back-end infrastructure. So it's always better for developers to know about the underlying infrastructure. However, the promise of serverless is that developers don't have to know about the back end in order to create a application off the bat. Processes that are events or batch driven in nature. So we didn't touch on this in the replay, but basically where servers don't play in, serverless doesn't play well, is if I wanted to create that encoder application, I can't really create that effectively using serverless technologies. So persistent databases, data services in general, it'd be kind of a poor idea, I think, at this point to create a serverless file server. That kind of makes no sense. And then we talked through the cloud and on-premises options. At least we highlighted them on the slide. You can go back, review that, and see all the different open source options, as well as the cloud-based options from the major cloud providers. I hope you enjoyed this replay of the video. A little bit different feel without the questions back and forth, but hopefully if you missed it, this is a great opportunity for you to have caught up. If you want to learn more about serverless in general, visit the blog, thectoadvisor.com, where I talk about serverless and a ton of other activities. Subscribe to the YouTube channel. Talk to you next webinar.